If anyone has problem in Newton, please raise. I can wait. Okay, can I proceed?
Yes,
Who's that for Deepti or Saudina?
Saudina.
Yeah, any problem you are facing?
No, I'm good.
Okay, shall I continue now?
Yes.
Yes. I told that big data is a huge data, okay, but actually big data is a problem. It's not any technology. Someone, I think you have heard, I'm learning big data Hadoop. He is working on big data Hadoop. There's no word like big data Hadoop. There's only word Hadoop. Big data is a problem actually. Okay. Okay, what kind of problem? I answered big data is a problem. Okay, but we need to understand what is the problem actually. What kind of problem it is, and how do you define the problem, and how do you solve the problem? These three things we need to know right now. Big data is a problem related to storage and processing. Big data, as you said now, we transferring data from one server to another server, huge data from one server to another server. Just not transferring, storing it and processing it and transferring it. So big data is a problem related to storage and processing. You just you just listen what I am trying to say. After 2 to 3 slides, you get a brief idea. Okay? Yes. And how do you define this problem? I said big data. What kind of problem is? It's a problem which related to storage and processing of the data. Okay. There are problems in storing the data. There are problems in processing the data. That is a problem related to big data. Okay. And how do you define that problem? We will define the problem with 3 V's. V stands for 3 V stands for volume, velocity, and variety. With respect to these 3 terms, we will define the big data problem. Okay. And after that, we will see how to solve it. How we solve the big data problem. First, we need to know the 3 V's of a big data. As I said, volume, velocity, and variety of the data. We need to see the 3 V's of big data. First, let us see the volume. What is volume related to? Follow me?
The amount of data that is.
Yes, the amount of data, volume. These are the simple terms which we learned from the school. Volume is related to size of the data. Size in the sense bytes, starting from bytes to zettabytes. What are the measurements we have totally? Everything, even from bytes to zettabytes, it's related to volume. And velocity related to speed. Yes, I think all of you have heard the word velocity, right? Yes, velocity, speed. What speed? What kind of speed? It's related to RAM speed, network speed, and data traveling speed. See, today, what is the typical size of RAM in your laptop? It's around 4 to 8 GB, right? So when we are using 4 GB and some advanced users are using 8 GB and 16 GB. In the same way, companies, those which are dealing with large amounts of data, I think US company servers you are seeing more than that, 64 GB RAM also, and 128 GB RAM also, based on the amount of data they are processing. Typical speed, let's say 1 GB to 100 GB of RAM speed. Okay? Yeah, in very huge companies, very large companies like Facebook and Google, even they use terabytes of RAM. RAM itself is terabytes, 1 TB, 2 TB RAM. I mean, you'll come to know why they are using such huge RAM. And network speed. What is the network speed? Network connection speed. The amount of data traveling through the network per second. It's typically from 1 Mbps to 1 Gbps. Okay? And what is the largest, have you heard what is the largest network speed you have heard till so far? So now? Highest network speed. It's around 60 Tbps. Right now they are planning to implement it. And it's under process from I think Japan is doing that, 60 terabytes per second. That's the network speed. See, assume how much data flows through that cable. 60 terabytes per second. Just assume it. Your laptop itself, I think maximum capacity is 1 TB. No one has more than that. Hard disk 1 TB. 60 terabytes per second. The cable is traversing the data. Who will store that data? 60 terabytes of data per second means who will store and how to process the data? This velocity actually created the problem of the big data. And variety.
Raven, one second.
Yes,
You
yes.
said about data traveling speed. That is also related to network speed or is another?
No, network speed. I said data traveling speed in the sense keeping in mind network speed in mind. See the network speed if you are using 1 Mbps, 8 Mbps typically we use at our houses, 8 to 16 Mbps.
Yes, yes.
And in companies they use more than that.
Yeah.
Yeah, if the speed is 1 Gbps, the data traveling in that, the packets traveling in through wireless network is huge, right? Yeah, okay. And the third is variety. Variety means different types. This is also familiar word. Different types of data. Volume in the sense size of the data, velocity in the sense speed of the data, variety in the sense types of the data. What are the types of the data? What are the yes.
Videos.
Yes. Documents, videos, okay. And
Social network type of data.
yeah, social network data. The data also includes all kinds of data. Let's see the varieties of the data. Yeah. They are classified as 3 types: structured, semi-structured, and unstructured. Have you heard these words before? Anyone? Yes. If you're willing, please just say 1 or 2 words. Structured, semi-structured, unstructured. What does that mean? Okay, yes, I'll proceed. In a world, there are only 3 kinds of data: structured data, semi-structured data, unstructured data. You need to know all these basics before we go to start Hadoop. That's why I'm telling all this. What is structured data? The data which we can store in RDBMS. RDBMS in the sense normal database, Oracle database, MySQL database, anything, my Microsoft MySQL server. Any data which we store in a normal database, available RDBMS, relational database, that we can call the data as structured data. The data has definite structure. We know each and every data type of the data, the minimum to maximum length of the data. We know about everything about the data. That data can be called as structured data. Okay? Got it? And semi-structured data. You can see here XML files, Excel files, log files, and recently leading the market is JSON data. JSON in the sense it's related to Java. It's replacing the XML data. I think Deepti should have heard this word, JSON data. Yeah. Differentiate between these two, structured and semi-structured. What is RDBMS data? How does it look like? And what is unstructured, semi-structured data? How does it look like? How does XML data look like, and how does the data in RDBMS look like? Typically, what we have in the RDBMS data, how the data in the RDBMS will be. We have a number of columns, variety of columns. It may be a character column or string, or it may be integer, or it may be decimal number. Something we know that each and every data, we know the characteristic of the data, right? Semi-structure. Let's take XML. We know this in XML what are the contents of the XML. Generally, we have starting tag and an ending tag in between data, right?
Yes.
Yeah, XML contents are those. XML it is not completely unstructured. We know that data when a subset of data starts and when a subset of data ends. In between we have the data, so we know partially about the data. In between the starting and ending tag, we can have a single line, single word, or a 1000 pages thing. Okay? The data semi-structured. Try to understand this. It is not completely known, completely structured like RDBMS data. Are you getting a point?
Yes.
Yes. Everyone, are you following everyone? Everyone is online?
Yes.
Yes. Yes. And the third type is unstructured data. Unstructured data in the sense audio, video, as I said now, social networking data, video data like audio files, video files, emails. Yeah, just before half an hour we communicated through email. Does that email data have any structure like RDBMS data, tabular form data? In email we just write the sender name and you can write whatever you want in the data. It doesn't have any structure, defined structure, right? And bioinformatics data, in the sense of data, bioinformatics in the sense, your scanning data, scanned files, everything like that. Okay, now try to understand the difference between these three kinds of data: structured, semi-structured, unstructured. Just in clear point. If you have any further doubt, please ask me. Because you need to know the difference between these three kinds of data. Okay?
Yeah, we are okay with that.
Yes,
Yes. Let me proceed further. This is the first B of big data. And the second is volume. We spoke in the previous slide regarding velocity. I said velocity in the sense RAM speed or network speed. Data income. If network speed is more, and if velocity is more, the incoming data to the server is more, right? Suppose if we have 1 Mbps internet line, we get little amount of data. Suppose if we have 1 Gbps line, what is the quantity of data you are getting into a server, into your system? In the same, if you have RAM speed also, if you have high-end RAM also, the data processing speed also increases. If you have low-end RAM, you couldn't process the data as much as speed as we have the higher RAM one. Okay? See, what I'm trying to say is, due to increase in velocity, data volume is also increasing. The data we are incoming, the data we are getting also increasing due to the increase in the velocity of the data. How does this velocity increase? Through network speed. Okay? Yes, for example, take your mobile phone with and without internet connection. If you have a mobile phone in your hand, think that your 3G is off and you don't have any network connection. What will you do with that? Yes? Hello, what will you do with that mobile if you don't have your internet connection? Are you generating any data there? No, you just see your mobile phone each and every app. If you have photos and videos, you will watch that and you will shut down the phone. That's it. But if you have internet connection to your mobile, you can log into your Gmail, you can log into your Facebook account, Twitter account, you can log into your App Store or iTunes, you can download the apps, you can send the data to someone else. You are generating the data there. That is the basic point where the data problem, big data problem is starting. You are generating the data from your hands with the network connection, with the velocity. You are increasing the volume with the available velocity. Okay? You are getting it? Yes. So the data is generated, where all this data goes. The data you generated, you generate some data. You suppose, for example, Facebook post. You post something in Facebook, you post something in Twitter, you write a mail to someone, you send an audio file, video file, everything. Where does this data is going? Where is this data going? Every data is going to store in the company's respective company's servers. You suppose you are posting a video on the Facebook. You went to Paris and you are posting a video in front of Eiffel Tower. Where does the data go? It is going to store in the company's server. And these companies require storage devices and processing software to manage the data. See, I think everyone of you have Facebook accounts these days. You will upload photos and upload videos. For Google reference, if you want to send private albums, you will upload it in Picasa. Every single person now are generating gigabytes of data. If you have a digital camera in your hand, if you click one photo, the typical size of one photo is around 5 megabytes on a digital camera. In the sense, assume that how many photos you are taking, how much data have been generated. You are not going to store this data. Simply you are going to use the Google Drive or Microsoft OneDrive, SkyDrive, or anything, Apple iCloud. Those guys have to store the data to make their business. Those guys need storage devices. Assume that only one person you are generating so much of data from photos, videos, audio logs, application downloads, apps downloads, and you are uploading the data to, and telecom data, everything. Assume that one person is generating so much of data. How about each and every person in the world? There are 8 billion people in the world. 4 to 5 billion people have access to the internet. Assume the amount of data they are generating. Ultimately, who need to store the data? You store the data which is required by you only. You doesn't need my data, and I doesn't need your data. But company needs everyone data to make business. So they need to store such huge data, and they need to process such huge data within less time. What you understanding? Yes. So how do they store the data? What do companies do typically? The only one way which strikes for us storage means database, right? You can't store the data in any other places. You can store in disks, but the traditional way is to store in databases. IDB members, relational database management systems. Teradata itself is a kind of database, and data warehouses, connection of databases. Yes, we can store data in this, but it has a drawback. You can see that the best for megabytes and gigabytes, sometimes terabytes. This Teradata and data warehouses, they support terabytes too, but RDBMS not mostly. Even if they support from 1 to 10 like that. But the incoming data, the data which you are generating, overall combined, it is more than terabytes, petabytes and exabytes of data. So are relational databases sufficient to store such kind of data? Can they store such huge data in relational databases? Everyone hearing me? Yeah. The typical size, typically relational databases are around gigabytes, and mostly they support 1 or 2 terabytes, maximum to 10. I think we can't afford so much beyond that capacity for a relational database. Okay? So we can store a definite limit of data in relational databases. We can't store more than that. And when it comes to processing, what if we want to process such petabytes and exabytes of data? In general, we use business intelligence tools and ETL tools to process, to extract the data from one server, to process it and to load in another database or another data warehouse. What is the typical size of the data you are processing and dealing with? And what is the capacity of ETL tools and BI tools? They can't handle petabytes and exabytes of data. Anyone have seen handling such huge data? ETL tools? So what I'm trying to say is, since the data is very huge, petabytes and exabytes, traditional storage systems and traditional processing systems are not capable to handle them, or not capable to store them, or not capable to process them instantaneously. You can process, but it takes days of time, but it's not desirable. We need results within seconds. So it's hard to process within such less time. Okay, got it? And the solution is integrating them. What you will integrate? What with what? See here, relational databases with big data. It's a big data solution actually. Relational database related storage with big data storage solution. It's commonly called big data storage solution. When you integrate big data with processing mechanisms like ETL tools and BI tools, it's called big data processing mechanism. You can solve this problem by integrating databases with big data and processing mechanisms with big data. Okay? Let's see how we easily solve this problem further. Before that, I'm saying from past 10 minutes that we are getting huge data, petabytes, exabytes. Do we really use the data? Do companies really use the data, such kind of data?
They are storing.
Yeah, one more. Yeah. Dipti, continue.
For future reference, they will store.
Yes. It means that they use, right? What I'm trying to say is petabytes, exabytes of data, are they using it, are they storing it, or simply I'm saying in my words? They're using it. And Madhuri, she went out now. Hello, Madhuri. Madhuri, can you hear me? Please respond.
Okay.
Can you hear me, Madhuri?
Actually, we can
Yes. I think we missed half an hour. No one is not a very tough one.
we did not come
Yes. See the data amount of data. What? Someone said something? Yes.
the last case going.
What? Who's that speak, please?
The last 10 minutes we need to complete.
Who's that? Madhuri? You are speaking.
Last 10 minutes we need to talk.
I can't hear you properly. Last 10 minutes?
I need the task.
Okay. That's no problem. I can explain it further by seeing the slides, okay? Okay guys, for Madhuri, because spare 2 minutes please. I'll go very fast. I'll divide 1 second please, within 2 minutes, okay?
Okay, sir.
Comfortable everyone? Yes. Madhuri, nothing I said, just see here. First of all, I asked what is big data and what is Hadoop, okay? Before going to Hadoop, I asked her what is big data. Big data is a problem, and we are trying to discuss about the problem. Madhuri, are you on the track? Yes. Sabir, what kind of problem it is? How do you define big data and how do you solve it? I just said big data is a problem which is related to storage and processing. And how do they define? We just define the big data problem with 3 ways: volume, velocity, and variety. Madhuri, just see the slides. Just read fastly. Read for yourself. The data: velocity, volume, variety. These are the 3 V's of big data. We define big data by these 3 V's. The data which generally follows these characteristics comes under the category of the big data. That data only creates problem. The data which has high velocity, the data which has high volume, and different varieties of data creates problem for processing. And that data is only big data, okay? That's a brief thing. And I went briefly what is variety and what are the different kinds of data and what is the data related to volume, how we are generating the large volumes of data. You can easily understand this by seeing the slides. And now here we are. Now you see the statistics, how each and every company are using the data. Google, it is around 400 petabytes per month. What is a petabyte? What is the sequence of data? So starting from, we know everyone megabytes, then gigabytes, then terabytes, after that petabytes. 1 petabyte is equal to 1024 terabytes, right? Yeah. In the same way, Facebook, it uses 300 plus more than 300 petabytes per month. They are handling such kind of data. On averagely, roughly, they are handling 10 petabytes of data per day. Facebook, they are processing, they are handling it, 10 petabytes. In the same way, eBay, Avatar, they're taking one graphical image of an avatar. They require to generate 1 petabyte of data, such huge data. The overall movie, it took 100 plus petabytes for them. What? They generated 100 plus petabytes. They have to store the data, right? Yeah, without storing the data, what's the need to generate such kind of data? Same way, UIDAI, this is Aadhaar card, this is Aadhaar card project, UIDAI, the first prestigious project in India. It's a Hadoop project. It has 120 plus petabytes of data within their hands. We all give our fingerprints, eye scan, image, and normal data, right? When generating our Aadhaar card. So, it's a huge data to store for all of the fingerprints and photo and eye scan. It's not small data. So these companies, these are the way, some companies, there are lots of companies like this using and processing huge data. At an average, every company, maybe it is a small scale or large scale, I'm saying the average figure. Nowadays, they are processing 1 terabyte of data per day. At an average in the world, 1 terabyte of data per 1 day. Maybe it's a small size company, on an average, small to big company. See here, I'm talking about the data since half an hour because data is such much important. See the trend of the data, how the data is growing from the past years to the current year. The graph is from 2006, you can see here clearly. On the x-axis years and y-axis, the size of the data. You can see here exabytes, 5,000 exabytes. You can divide it by 1024 so in order to get the zettabytes. You know, see this figure? Yes. What do you observe from this figure? The figure is related to data growth. Yes, speak please. Right now we are in 2016. We are here. See the graph. This graph is related to the size of the data growing each year. In 2006, you can't see anything here. Very less data. Year by year it is growing. And 2020 they are expecting this much of data in the world. 35,000 divided by 1024. It's around 35 zettabytes of data. The total figure of the world's data I'm speaking. Okay? And we can see something here. What is this blue colored ones and what is this orange colored ones?
Orange is unstructured.
Yes, exactly. Orange is unstructured data. The data which is generated by machines, social media data, VoIP calls. The one we are generating the data right now, it's also falls under unstructured data. This meeting data. And this is enterprise data. Enterprise data is around, it's very less here. Not only here, in each and every year. Enterprise data in the sense, it's structured data, the data which you employees generate by sitting and by typing on your desktop. That is enterprise data. What I'm trying to say here is, no matter how the data is, 80% of the data is structured data in the world. Okay? Did you get an idea about this figure? The trends of the data each and every year. Everyone. Everyone, okay? Are you following? Hello. Yes, so far so good. Everyone okay on the track now?
Yes, sir.
Yes. Can I proceed further?
Yes.
Yes, if you have any problem, please stop me. I can wait. See, as of this figure, 80% of the world's current data is generated in the last 4 years. Before that, we used to have very, very less data. Why? Because internet has gained popularity these days. Everyone is trying to use mobile phones. There are lots of sensors, machines. Due to the network and network hardware velocity also increased. Nowadays we are having higher infrastructure. Due to all these reasons, data is growing rapidly from the past 4 years. Let's see the sources of data. It's okay, but from where this data is coming? What are the sources of this data? I think two guys are disconnected. Saudani and Madhuri, you muted yourself. That's okay. Okay. Let's see the big data sources now. We are getting data, okay, from where we are dating. We know some sources. Let's see the different variety of sources. All of you try to see this figure and take 1 minute and observe the figure. Okay? What does it contain? Okay. You can see three semicircles here. The first one is business process, second one is human enterprise content, external sources, third one is machine data. Then the regular source of circle, the area of the circle also represents the type of the data we generate. This is a normal data, business data, and the previous figures have seen that structured data, only 20%. Okay, that's where the data is here. And the human generated data, we are generating more data than the business processes, web blocks. Every time we log into a web, a log file is generated. Every time we log into an email, a log file is generated. That's one source. Emails, it's a common source of communication today. Documents, PDF documents, Word documents, presentations, each and everything. Social media data that we generated. All these are the things you are seeing in the second semicircle are generated by us, human data. This is also less when compared to machine data. Now let's come to machine data. What is machine data? You see you can see that the sources of machine data: bioinformatics, control logbooks, recordings, videos, sensors, satellite data. Just try to imagine what kind of data each of them generates, and what would be the size of the data. Follow me?
Hello?
Yeah. Again, very much following me?
Sir, there is lot of distribution.
Lot of disturbance. Okay, I'm muting all of you guys. Just listen my voice for 10 seconds and then respond to my message. Still there is disturbance or not, okay? Okay, I muted all of you guys. If you still find any difficult or if you still find disturbances, please notify me. Are you clearly able to hear now? Yes? Yes, able to hear. That's good, yeah. Okay, I have muted you all. If at all, if you have any doubt and if you raise and want me to stop, please message me. I can't hear you right now, so since I muted all of you. Okay, so from this figure, where the amount of data being generated by different sources, various sources of the data. There are lots of sources apart from this, but I am giving a simple example. In some categories, some examples from some categories. What is sensor data? What is satellite data? Sensor data, nowadays we are having sensor everywhere. Even if you go to office, when the fans and lights are switching automatically, those are all sensor data. They all contain sensors. The processor data, they observe the motion and they will run automatically. They are generating some data that is unstructured, purely unstructured. They don't have a particular structure. And satellite data, when it comes to satellite data, what is satellite data? Nowadays we are having thousands of satellites, many satellites from each country. For each task, for military we have satellites, for GPS navigation satellites, for sea routes we have satellites, everything, for each and everything we have different satellites. Assume how much data we are going to generate from each and every satellite. So think of example, NASA and Hubble telescope. Hubble telescope, it's around 20 years it's been launching. And nowadays we are able to find the interstellar objects, interstellar planets, and different galaxies we can observe from Earth with the help of Hubble telescope. Why? Because Hubble telescope, it's capturing the images from interstellar space and it's sending back to NASA. As well as size of the one image, how much would be the size of the one image sent by a Hubble telescope? Normally, if you take a photo from our digital camera or from our phone, it's the typical size is in megabytes, 4 to 5 megabytes. How about the image sent by Hubble? Assume the size of the image sent by Hubble. It's in terabytes. A single image is in terabytes. Hubble has been launched from 20 years. It's functioning. Assume how many images it has been sent to NASA. And what is the total size of the data? What NASA have to do with that data? They have to store it. They have to process it. Okay? Without that, we are waste by sending so much of data from Hubble. See, this is only one source. Hubble telescope is only one source of data like that in the world. Assume how many sources are there. I'm going to explain you one more source. See this. See, if anyone in between want to ask anything, or if you feel uncomfortable, or if you want to stop, please message me. Since I muted all of you, I can't hear anything from you, right? I can't hear anything from you now. I muted all of you. Just message me if you are having any doubt in between. This is since we've seen the Hubble telescope example and see the flight example. A flight has thousands of sensors in a single flight. You can't see that, but it has thousands of sensors. See this example. Everyone clearly read this example. No? 20 terabytes of information per engine every hour. Typically, a flight has 2 engines, left side and right side. Each engine is going to generate 20 terabytes per hour. So, like that, a flight has 2 engines, typically. Assume that the 6 hours journey for a typical flight into number of flights in the US. This is just an example of United States. Number of flights per year. Number of flights in the sky in the US in a given day for total year. Assume only flight airline sector. How much data airline sector is going to generate only in the United States per year? You can see when you add this by 24 into 24. It's around 2 zettabytes. I calculated. It's around 2 zettabytes of data per year. The world's current data is around 10 zettabytes. Only United States Airlines going to generate 2 zettabytes of data per year. Assume the world airlines, how much data they are going to generate. Now assume the size of data. Does relational databases, okay, does relational databases apt to store these huge data and these varieties of data? Can you store image files? Can you store audio files in relational database, in Oracle database and MySQL database? Can you store audio files, video files? Of course, image files in the sense somewhat it is okay. We can create store in binary form, or we can give a link. We can give out to audio file or video file. The audio and video file in the cloud. We will be in the cloud and we will have the link stored in the databases. But we don't store the exact audio and video file in the database. And when it comes to processing, normal databases, does these normal databases able to process such terabytes, petabytes and exabytes of data? Clearly they cannot. Because the data is very large. Simply say no, we can't process such huge data. That is what big data about. That is where the big data problem arises. Like Y2K, before 20 years or 15 years you have seen the Y2K problem. It's very popular. In the same way, nowadays big data. Now, I think you all understood the problem of big data. Now, so far so clear?
Sir?
I unmuted all of you. So far so clear? Have you understood the problem of big data? With these examples. Yes, that's good. In the same way, let's see what happens in the internet. Observe this figure. What happens online in 60 seconds, within a single minute? What's going to happen in the internet? By some this, you can assume how much data is going to generate in 1 minute throughout the world. My intention is to show you how this data is going to be generated. This is from 2013, 14, 12, 13, 14. Still 2016 is not there. Just see the 2014 data. In 1 single minute, 204 million emails sent, 3.3 million Facebook posts. In 1 minute, everything in 60 seconds. 4 million Google searches, 40 lakhs of searches per minute. Google is handling 40 lakhs of searches. All these are generating data. Instagram, Skype, Twitter, blogs, WhatsApp, and videos. 120 hours of videos are being uploaded by everyone in a single minute in the internet. Just assume how much data is being generated in 1 minute. Where all this data goes? All this data have to be stored and have to be processed and have to be retrieved by the companies. Because we are users, we don't bother about the storage. We just generate the data and we just want the results. But companies, they are suffering to store such huge data. They are suffering to process such huge data. That is where exactly the big data problem arises. That is what the big data is. So, does this problem have a solution? Do this problem have a solution? In a sense, yes, this problem already had a solution 10 years before only. Let's see what is it. What are the available solutions of the big data? Right now, in the market, there are 3 solutions. Okay, it's 10 o'clock around. I'll finish it very fast. Guys, everyone have to know at 10 o'clock exactly, or it's okay if I take 15 minutes more? Is it okay?
It's okay for me.
Okay, just 15 minutes more today because we delayed in correcting in the beginning. Okay. Yes. Now see, what are the 3 solutions, available solutions of the big data? One, NoSQL databases. The first solution is NoSQL databases. What is NoSQL database? Have anyone heard? Do anyone know related to? Yes? Certainly, I think. Anyone have idea related to NoSQL databases?
No idea.
Yes. NoSQL in the sense, N stands for no, O stands for only, not N stands for not, O stands for only. Not only SQL, not only structured query language. In normal databases, relational databases, RDBMSs, it's opposite to RDBMS. We have only structured data there. We have relations between the data there. But when it comes to NoSQL databases, it's different. It handles each and every type of data, structured, semi-structured, and unstructured also. Unlike RDBMS. The definition itself is not only SQL. I can handle anything. Not only SQL. Any type of data. Okay. The best examples are HBase, Cassandra, MongoDB, Bigtable. Like that, around 250 NoSQL databases are there. We can store petabytes, exabytes of data in these NoSQL databases. Unlike RDBMS, unlike Oracle database, unlike MySQL database, we can store any amount of data in these databases. But we can store audio files, video files, everything we can store in these databases. And the second solution is Hadoop. That's what we are able to. That's what we are going to learn this course, Hadoop. Hadoop is also a solution. Hadoop is not only the solution. Hadoop is one of the solutions of the big data. Hadoop internally has three parts. You see this HDFS. This is related to storage. Big data, we have seen that big data is a problem related to storage and capacity, and we have also seen how it affects storage, how it affects processing. So HDFS, there is a component in Hadoop called HDFS. It handles storage. It says, okay, storage problem, I can handle the storage problem, I can see. And there is another thing called MapReduce. It asserts that, okay, you HDFS, you handle the storage part and leave the processing part to me. It takes care of processing such huge data. And from 2013, there is another component included which is known as YARN. See the definition, yet, Y-E-T, yet, another resource negotiator. Don't worry, I'll use everything notes for you later. Just see the components of the Hadoop. These are the three components of the Hadoop. Hadoop is one of the solutions which contains these three components. And the third solution is Hadoop plus with ecosystem. Yes, please.
So, you can explain.
No, I can't hear you. Please repeat.
Another?
Yet another resource. R-E-S-O-U-R-C, a resource negotiator.
Okay.
Yes, another resource. Yet another resource negotiator. It is the resource management. In order to process a huge kind of data, resources have to be allocated accurately and efficiently. That part takes care of by YARN. Processing is by MapReduce only, and YARN takes care of that. Totally it improves the Hadoop performance. Yes, and the third one is Hadoop ecosystem. Hadoop ecosystem in the sense, these are the, no, not only these are, there are total lots of components like this. Ecosystem components. All these components work on top of Hadoop. First, we need Hadoop. On top of Hadoop, we have to install these components in order to make life easier, in order to make processing still easier. This also requires Hadoop internally. As of now, just see the names: Hive, Pig, Scoop, Flume, Uzi, Spark, like that. Lot of things. Lot of ecosystem components are available. Zookeeper, Kafka, Nuts, everything. Okay, what I'm trying to say is, there are solutions for big data, and there are three solutions for big data. First one is to store in NoSQL databases. Second one is Hadoop. Third one is Hadoop ecosystem, right? Okay, so far? Yes. Let's see little deeper in that. And NoSQL databases as let's see the first solution, NoSQL databases. What is the advantage to store NoSQL in NoSQL databases? It is scalable, unlike relational databases. Relational databases are not scalable. They are only confined to a certain server. Depends on the storage capacity of that server. But when it comes to NoSQL databases, we can add any number of nodes, any number of servers, any memory. Initially configured with certain memory. So if memory is insufficient, we can go on add nodes, add memory to that. So in that way it is scalable. So in that way we can store huge amounts of data. But there is a drawback in NoSQL databases. What is the drawback? We can also see there is one more advantage: speed. We can also get the results very, very fast. Suppose think a small example. We have RDBMS, Oracle database. There are not 10. There are 10 rows in a table. In a RDBMS, in the Oracle database, there is a table, and the table has 10 rows and 5 columns. A little small table. Suppose you want the fifth row. You want fifth row, and the primary key column is 5, suppose 1, 2, 3, 4, 5, serial number 1 to 10, suppose. You want to retrieve the fifth row. What you let? Select star from table name, where primary key or student ID equal to 5. You will give the primary key. You will get the result. In what time you will get the result? Only a table with 10 rows. It's milliseconds, right? Not even a second, milliseconds. Yes.
For 10 rows.
In milliseconds. Assume I said a single table with only 10 rows. It doesn't take much time, not even a second. In milliseconds we can get the result, right? So for the same Oracle database, for the same table, data keeps on adding. Suppose the table has number of rows,
It will take
10
time.
million. Yeah, it will take time. It will take, sometimes it takes hours of time. Even though it has primary key, even though the data is indexed, it takes hours of time. But the same table, table with same 10 million rows, if you store the data in NoSQL databases, like one of these databases, HBase, Cassandra, MongoDB, Bigtable, so on. Because if you want to retrieve the same query, you will get the answers in seconds, not even minutes. You will get the answers in seconds. That's the power of NoSQL databases. You will come to know why it happens, because in normal databases we have only normal indexing. When it comes to NoSQL database, we have content level indexing too. I will explain it in further, because all these topics are going to cover in the Hadoop concept, in our Hadoop course. These are the advantages of NoSQL databases. But the disadvantage is it can't store data in the form of a file. What is file format? Generally, how the data is being stored in a database? Say, tables, columns and rows, right? Yes. Do we store files in the database? Files in the sense, suppose a notepad, if you have 100 MB of notepad, can you store that file in databases? We have an audio file. Can you store an MP3 song in the data file? Can we store? Any idea? Yes, we cannot store. We can sometimes some images are being stored by referring, by indexing that image to an external link. Somewhere we'll store in the cloud and we'll give the link. We'll simply store that link, but we cannot store the total file there. In the same way, the disadvantage of NoSQL databases it cannot be able to store the file format. But in big data, in huge amount of data, we have file formats also. We have audio, video files also. We have notepads with 100 log files. If you see log files, it's around megabytes of log files are there. Sometimes gigabytes also. All these kinds of data are present in big data. But what the good if NoSQL databases cannot be able to store those files? Due to only this reason, this solution is failed. Okay? This solution is failed because of this only single reason. It cannot handle file format. The data which we store, even though you store 100 millions of records, everything is going to be stored in the form of rows and columns only, but not in the form of files. So it's failed. Now comes our hero, Hadoop. This fellow supports everything. Says that no matter what kind of data, no matter how much data, I can store it and I can process it. That is the power of Hadoop. Let's see how. As I said previously, storage part is handled by HDFS. Don't worry about the definitions, don't worry about the acronyms. Just concentrate on the time storage, processing, that's it. I'm going to explain what is HDFS and everything further. Storage part is handled by this HDFS component. The processing part is handled by MapReduce component. The phenomena which is going to be observed in MapReduce is distributed parallel processing. As of now, they estimate storage and processing. Don't concentrate on our words. And the third one is Hadoop ecosystem. Hadoop solves this problem. Hadoop ecosystem adds extra features to Hadoop. These ecosystem components are this Hive, Pig, Scoop, Flume, Hive. Hadoop is built on Java actually. Diti worked on Java, right?
Yes.
And yes, and the remaining guys, Madhuri and South Indian, they don't know Java, suppose. Hadoop is written in Java, so it's easy to write program is easy to process things in Java. We can write in Python or language also, but it's better and it's comfortable to write in Java processing code. But what about the people who don't know Java? Actually, I am not a Java guy. Actually, I know a basic Java only. So people who don't know, who don't have any background from Java, for them, they are also able to they have to use Hadoop, right? Like other guys. So for them, the ecosystem component have been introduced by Facebook actually. It uses HQL, which is similarly like SQL, 80% of the SQL. So even if you don't know Java, you can use Hadoop. You can process through Hadoop with the help of Hive. SQL, yes, I'm talking about SQL, guys. In the same way, even if you don't know SQL, you can use scripting to write code and to process data. This is for Hive is for SQL guys, Pig is for scripting guys, like that. And Scoop is related to transferring from RDBMS to Hadoop and Hadoop to RDBMS and vice versa. From real-time data streaming access. When suppose if IPL match is going on, think how much of data, how much of everyone in the day tweets about the IPL matches right now, or if a football match is going on, we get lots and lots of tweets during the time of that match. How much of data Twitter is getting entirely in the total span of the match? If they want to analyze the data, they have to capture the data in the real time. This component helps for that. In the same way, Uzi to scheduling the jobs. Okay. So let's see formal thing now. Definition: what is Hadoop? Hadoop is a solution for big data, the best available solution, not only a solution, the best available solution until now. See, this is the definition actually, actual definition for Hadoop. Everyone just try to read this. Hadoop is an open source software framework. It is a framework. It is not an application. It is not an app like Skype. It is not an app like any other thing. It is a framework. It is a framework for distributed storage and distributed processing of very large data sets on computer clusters built from commodity hardware. Commodity hardware in the sense cheap hardware. In order to store that petabytes, exabytes, and data, we need lots and lots of systems. So those systems are not so high cost, normal cost. That is what commodity hardware means. As of now, just see the definition. Hadoop framework consists of, as I told this previously, HDFS and MapReduce. And this is a little bit different thing. All the modules in the Hadoop are designed with a fundamental assumption that hardware failures are common. So Hadoop takes care, even though there are failures in hardware, failures in the nodes, Hadoop will take care of that, and data will not be gone anywhere. There is no loss in the data. Such a capability Hadoop provides. Let's see the evolution of Hadoop. The inventor of Hadoop is Dow Cutting. Hadoop came into existence in 2007, 9 years from now. Actually, in 2002, this guy, Dow Cutting, is working on a project named Nutch. It's a web crawler. He and his friend working on a project called Nutch. And during the time in 2003, Google, the hero, it's ahead, 10 years ahead of the world. What we are seeing the technology right now, it's 10 years ahead. So Google first published a paper named GFS, Google File System, to handle the storage. We'll have to, as previously seen, how many searches are being handled by Google in 1 minute. So they have got the problem in the early 1990s only. 1990 only. So after 13 years, in 2003, they published the paper Google File System to handle the storage problem. After this, in 2004, they handle the storage, so they have to process it. In 2004, they published a white paper named MapReduce. Actually, the file system storage and the file system processing is first, this idea given by Google to the world. Google is the hero first here actually. So 2004, this Dow Cutting took this idea of the Google and he implemented in his project. And he created a storage mechanism called MVFS and MapReduce. After that, In 2006, he joined Yahoo. Yahoo invited this Dow cutting. Hey, please come to my Yahoo. Let's develop this Hadoop project. Means he joined in Yahoo, and there he developed HDFS and MapReduce, which are the components of Hadoop. 80% of the current Hadoop. Right now what we are using, 80% of the Hadoop. Originally developed by Yahoo in 2006. Later in 2007, they made open source to the world. They gave a source code to the world. This is the history of Hadoop. When it comes to distribution, what is the distribution actually? Distribution in the sense, customization. See, you can see here, we have seen Apache Hadoop. Apache is an open source software foundation. Any software which came from Apache, we can have the source code. It is an open source software. It is not a proprietary. We don't need to buy it. It's a free software. In the same way, these fellows, Cloudera, distributions of Hadoop, let's see Cloudera, Hortonworks, MapR, Greenplum, etc., etc. These Cloudera is the first company to take the source code from the Apache Hadoop. They took the source code from the Hadoop, from the Apache Hadoop source code from Apache. They added customizations. They added their own masala. They made customizations, and they made as a package, and they are selling to companies. They also provide support also. If they are selling, means they should provide support, right? Apache Hadoop, even if it is an open source, they they will give the support, but not as quickly as paid services. So these are what the term distribution means. This. These fellows took code from Hadoop and they customized as they like, and they're selling it into the market by providing support. In the same way, Hortonworks, MapR, Greenplum, IBM has its own version, Dell, HP, Intel, Airtel, etc. Everyone is using. Everyone is making their own customizations in the market. The best and the most selling, the most used things are these two: Cloudera and Hortonworks. First two, Cloudera Hadoop, Hortonworks Hadoop. These are the two things widely used. See, if you host this Hadoop framework on the cloud means it's a storage thing like that. If the storage becomes huge, if the big data problems happen there, we have to host Hadoop there. Some clouds are hosted by Hadoop. See this, Amazon's EMR, Elastic MapReduce, Amazon Cloud, they are using Hadoop there in the cloud. And the name is Amazon EMR, Elastic MapReduce. Elastic MapReduce. In the same way, Google Cloud also, they hosted Hadoop in their cloud. Windows Cloud, Windows Azure, they given the name Windows Azure, they also hosted cloud, they also hosted Hadoop in their cloud. That's the thing actually. Today, enough for today. And tomorrow we will see the differences between file system, distributed file system, and Hadoop file system. In order to know what is HDFS, you need to know first what is FS, what is DFS. Okay? Yes. So guys, any questions now? Yes. If you have any questions, feel free to ask. And one more thing, what are your convenient timings? Is it okay if I took 10-15 minutes more or anything like that? Today it's already 10:20. No, I won't make this much delay from tomorrow. I'll stop mostly at 10:05, 10:10 like that, 10:05 also. Because it's office time, right? Everyone has to leave for office now. Okay, so good so far? Yes, okay. Let's start. Let's stop now. No questions until now, right? Okay. Yes, yes. If you have any further clarifications, you can email me. I can provide the supporting documents also for you.
Okay.
Have everyone downloaded the Ubuntu operating system?
Yes.
Yeah.
Yes, yes. I have given the documentation also. Try to install it just. If you have any further doubts, email me. Okay? Yes, let's end now. Thank you for listening. I'm ending the meeting, right? Okay?
Thank you.
Okay, bye. Bye. Thank you.
Bye.
Thank you.